let's talk about evaluating a piecewise defined function. So in a piecewise function, we're just talking about a graph that does more than one thing. So in this case, if we look at this, we have three different pieces going to our equation. We have the h of x equals 3. That's like saying y equals 3. And so that's actually a horizontal line that goes through y equals 3. And then the second piece, the h of x equals x plus 1 squared minus 2, is a quadratic. That's a parabola. And it's in vertex form, so I know that this is a parabola whose vertex is at -1 and -2. And then we have the h of x equals -1/4 x minus 1. And that's a linear function. It's a sloping line. It's a downhill because of the -1/4. That's the slope. The y-intercept is -1. And so basically, these are defined over here. That's where on the graph it does these different things. So you don't actually have to draw this out to think about it, but I want to give you a picture of what's happening in this graph. So if x is less than -2, so let's say -2, then we have basically a situation where here is 3. We have a horizontal line that's going along like that, and it goes all the way anytime x is less than -2. I drew a little open circle because it's not or equal to, so it's never at the -2. From -2 until not quite 1, we have this parabola. And remember, I told you the vertex is at -1 and -2. So here's -1, and then -2 would go down here. So I know it's a smiling parabola. So basically what happens is it comes down like this, and then it's going to do this until 1. And I'll finish drawing that in just a second. I should have probably just made these different colors. So here's the parabola coming down. And then let's talk about this part. When x gets to 1, it's going to make this line that has the slope, and the y-intercept is -1. I'm not sure it never actually does that. We'd have to think about how actually high up that comes. So just sort of approximating somewhere over here. I would have to get a little better, but from 1, we have this downhill line that goes like this, and the parabola maybe goes like that. So I may have not been super accurate with that, but so see how we have 3 pieces to this graph. The question says find the h of -4. So the h of -4 is, I'll turn into yellow here. Here's -3, -4, is something that lives down here on the left. And so the only graph that's happening here at -4 is right here. And it's right there on that line. And so the h of -4 has to be 3. There's really nothing to plug in or solve there because the graph is always 3 forever if it's less than -2. All right, then it asks us about the h of -2, and the h of -2 does not fall here because that's not or equal to, but it does fall here. So this equation will apply. So what I'm going to do is I'm going to take that -2. It's likely that it's pretty close to the 0, but let's plug that in. We're going to have x plus 1 squared minus 2, and we're going to take a -2 to plug in here. -2 plus 1. We're going to square that and subtract 2. -2 plus 1 is -1 squared is 1. And 1 minus 2 gives us a negative 1. So probably my parabola was actually a little something there. But so negative 1 is going to be the answer to the second one. And then h of negative 1, we go, okay, where is the h of negative 1? Well, it's not there because that's too far. It exists in that second one where we just were. It's in that parabola again. So I'm going to plug that number in to this. I'm at x plus 1 squared minus 2. So I'm going to say negative 1 plus 1 squared minus 2. This is 0. 0 squared is 0. Minus 2 is negative 2. And so that will be the value of h of negative 1. Just means that on negative 1 I'm actually dealing with. In fact, hey, look at that. It is the vertex, because if I go to negative 1, I will go down here to negative 2. Pretty cool. So the shorter version of this is when they ask some of these, they ask you about these right here. Gotta get a pencil here. Right here. You have to figure out look at these ifs and find out where that is, and then you plug your number into the equation that goes with that. Hopefully that was a clear enough way of saying that. Let me delete the screenshot here so we can go back and look at the explanation in Alex, and you can see them thinking about h of negative 4 is where the 3 is, and then the h of negative 2 in the middle one, and the h of negative 1 in the middle one, and they get the same answers that we do. It says show the graph. Let's see. Oh, there's the graph. Okay, so cool. I went ahead and connected mine higher. I needed to plug in some values to be more accurate with the actual piece of parabola that's in the middle. But the general idea was there, and we could get the answers from the general idea that I had going. So hopefully that helps.